Okay, last part of this chapter. There is solids, discussing solid हम states of matter में हम different type of material discuss कर रहे हैं. That is fullerenes. Any question from the previous topic? Zain and anyone? Okay. Fullerenes mean
सर
that is yes.
सर मेरा एक क्वेश्चन था सर, वो ये है कि जब हम वाटर के अंदर इम्प्योरिटी ऐड करते हैं तो उसकी वजह से उसका बॉइलिंग पॉइंट इंक्रीज क्यों हो जाता है?
There is elevation of boiling point and there is depression in the freezing point. You know, boiling point depends on or freezing point or melting point or any physical change. Primarily depends on intermolecular forces. So if you are adding an impurity, it means there is some disruption in the intermolecular forces in such a way that they are a bit weaker now. And particles separate easily. Their vapors formation rate of evaporation increase हो जाता है, vapor pressure बढ़ जाता है. तो mean intermolecular forces are disrupted. अच्छा, हम fullerenes it is basically हम इसे कह सकते हैं an allotrope of carbon. Carbon has many allotropic forms. What this means, when we use the word allotropic, it means what? Or what the phenomenon allotropy means? जब हम कहते हैं fullerene is a new discovery, a new allotrope of carbon, तो it mean हमें ये आइडिया जरूर क्रिस्टल क्लियर होना चाहिए. आप लोगों को होगा अभी के बच्चों कि allotrope क्या होता है. When an element, because O levels में इसका hint जरूर होगा, when an element exists in more than one physical form. ऐसा क्यों है कि एक से ज्यादा फिजिकल फॉर्म में है? Due to different arrangement of atoms in space. When an element exists in more than one physical forms, due to varying arrangement of their atoms in the space. These forms are chemically alike, similar chemical reactions, but physically different. और आप लोग क्या कहते हैं? These are called as allotropes. Not all the elements got allotropes, just like not all the elements got isotopes. अपने O levels के बच्चों की तरह isotopes से नहीं mix करना. Isotopes mean they are the atoms of the same element, but they have different mass numbers. They are the atoms of the same element. These are also the atoms of the same element, no doubt. That's why they have the similar chemical properties, because chemical properties atomic number पे depend करती हैं. But these atoms of the same elements are arranged differently. These are called allotropes. जैसे हमने देखा diamond, carbon is arranged in a tetrahedral fashion. Each carbon atom actually is at the center of tetrahedron, goes on in the same fashion. Continuous, never-ending, giant network of carbons knitted by a strong covalent bond. What can be stronger than a covalent bond? I always repeat this thing, that when a covalent bond is formed, it means both the nuclei, very strong positive charge nuclei, carbon has 6 protons in one, and they attract the same electronic cloud. They are locked in by electrostatic force of attraction between positive nuclei and shared electronic cloud, which is dominant over the repulsive force between the nuclei, and they are locked in for life unless you provide a very high energy. और आपको पता है डायमंड को तोड़ने के लिए 3500 डिग्री सेल्सियस देना पड़ता है. Then you break some covalent bonds. That is the reason. That is the reason basically that macromolecules, any macromolecule, should have a very high melting point, because you are not breaking simple intermolecular weak bond like hydrogen bond or van der Waals force में ID bond और van der Waals forces में dipole bond. Hydrogen bond फिर भी थोड़ा बहुत strong होता है to some extent. You heat water to 100 and then it breaks, and continuous heating will change it into gaseous form. पानी will not spill like milk. Never. कभी देखा गिरते हुए? But milk को आप देखें तो you need to be very careful. It goes off because intermolecular force there is negligible, very weak. But in this case of water, hydrogen bond is a appreciable intermolecular force. तो हम उसको उतना निगेट नहीं कर रहे. But when we are talking about a covalent bond, there is no matching. तो अगर कोवलेंट बॉन्ड्स कंटिन्यूस हैं तो मैक्रोमोलिकुलर स्ट्रक्चर. अल्लाह ताला ने डायमंड देखिए कैसे बनाया, और फिर ग्रेफाइट सेम कार्बन एटम्स, सेम कोल, coke, is arranged in form of layers, and the fourth electron is not allowed to bond. Mysteriously, fourth electron is staying what? Staying independent, delocalized. Keep on shifting. If it shifts here, repulsion may cause it to shift at the other p orbital, and so on. They are moving around, delocalized. But एक लेयर और दूसरी लेयर के बीच कोई कोवलेंट बॉन्ड नहीं, only weak intermolecular force. But they are the carbon atoms. They are arranged in hexagonal fashion. Normally ऐसे hexagonal layers होती हैं जो एक दूसरे पे lie कर रही है. So you normally show it like this. One hexagonal layer is lying at the other. That makes graphite very flaky and a slippery structure. So it's a lubricant used in heavy machines for, कल हमने पढ़ा, for providing a mean to reduce friction. But diamond और graphite में फर्क क्या है? There is nothing. They are both carbons. They have same atomic number. Difference is the arrangement is so drastically different that diamond is jeweled, shiny, crystalline, so expensive. Hardest of things nature has made, used in the tips of the drill machine. And graphite is so soft and slippery and flaky. So कितना difference आ गया physical properties. But chemically they are the same. आपसे किसी भी MCQ में, even O levels में पूछता है कि what basic proof आप दे सकते हैं कि they are the allotropic forms of the same element and they are basically the same element. तो आप कहेंगे हम उसका कुछ भी same amount ले लें. If you take 4 grams of diamond and 4 of graphite or any other allotropic forms and you combust them, only one type of product is produced. That is what? Carbon dioxide. I mean, there was nothing else inside. कार्बन ही था तो कार्बन डाइऑक्साइड बन गया. हाइड्रोजन होता साथ तो H2O भी बनता, क्लोरीन होता क्लोरीन ऑक्साइड बनता, सल्फर बीच में होता सल्फर डाइऑक्साइड बनता. देयर इज नथिंग इनसाइड, देयर इज ओनली कार्बन दैट इज कंबस्टेड. और मोर क्लियरेंस आप दे सकते हैं कि अगर आपके पास सेम अमाउंट यहाँ पे है तो यहाँ सेम वॉल्यूम बनेगा. Suppose graphite produce 200 cm cube, diamond same amount should produce the same if the mass is same. But not only these are the allotropic forms, बल्कि आप देखेंगे कि डायमंड कार्बन में when it turns to soot, it has a different arrangement. It smoke soot, और it mean जब वुड को बर्न करें तो वुड को बर्न करके जो कोल ऑब्टेन होता है सब चारकोल कहते हैं. थोड़ा लूज अरेंजमेंट होती है जो आमतौर पे हम बारबेक्यू के लिए कोल्स रखते हैं घर में. They are charcoals, burned wood. That is another allotropic form, or different sort of arrangement, very loose, sort of clusters and bunches type. It breaks up, turns to powder. And then there may be another bit stronger form, that is coke. These are non-crystalline forms like graphite, like coal, like charcoal. Coke is basically the one जो आप सुनते हैं coal mining. That takes quite thousands of years to produce, to form. And coke is harder form. But this is another allotropic form. Sometime in superstores, you can find these coke stuff for barbecue. And they last longer. But they have very thick carbon inside and with more of sulfur as an impurity. Not sulfur as a structure, but sulfur as an impurity. So they may be dangerous. In a closed area, sulfur dioxide and especially thick carbon mean they need more oxygen, and oxygen is only 20% in the air. So if they are not burnt in open place, they lead to the formation a bit more amount of carbon monoxide. 1% कार्बन मोनोऑक्साइड हो जाए तो डेथ हो जाती है. इसलिए कोयले जला के, चारकोल या कोक जला के अगर आप हीट ले रहे हैं तो इट मीन दैट इज वेरी डेंजरस एंड ऑफन डेथ टेक्स प्लेस बिकॉज ऑफ दिस कार्बन मोनोऑक्साइड. These are all allotropic forms. तो आप बॉन्डिंग, स्ट्रक्चर एंड प्रॉपर्टीज पढ़ रहे हैं इस चैप्टर. पर जब हम इसकी बात करने जा रहे हैं फुलरेंस की, तो दिस इज वेरी यूनिक. बकमिनिस्टर फुलरेन. I said unique because they are sort of simple molecules. It's not a macro one, but these fullerenes are sort of football-shaped molecules. Latest of the discoveries, they are football-shaped allotropes of carbon. May contain like 60 carbon atoms. May contain 30 carbon atoms. Okay, varying amount. Some more, some less. But it means carbon atoms can be counted. It means they are a simple molecule. But amazing thing, these simple molecules are in the football sort of thing, tomb sort of thing. इसको आपने एक वर्ड सुना होगा, इवन ओ लेवल्स में भी. अब याद रखें, कभी भी एक बात अपने जहन में रखनी है कि ओ लेवल्स में भी उसने एक सिलेबस आउटलाइन दी होती है और फिर वो एक्सटेंशंस करता है. बेस्ड ऑन दैट आइडिया एक्सटेंड्स, एक्सट्रापोलेट करता है. एएस में तो कोई लिमिट ही नहीं है, ए2 में. इसलिए syllabus is in outline, no doubt, but on the basis of the themes, on the base of the theme जो आपको पढ़ाई जाती है, उस पे वो एक particular structure देके तो पूछ लेता है. आपकी बुक ने भी ये लिखा हुआ है. fullerene is in the syllabus, Buckminster fullerene in the syllabus, लेकिन आगे graphene या आगे nanotubes are not part of the real syllabus, but relevant questions can come matching the theme of the macromolecules. तो जब फुलरेन की बात करें तो फुलरेन्स आर बेसिकली फुटबॉल शेप मॉलिक्यूल्स. दे आर एंड टूम लाइक भी कहते हैं बिकॉज जिस बंदे ने डिस्कवर किया उसने इसका नाम रखा बकमिनिस्टर फुलरेन्स. एंड इट इज सेड दैट बकमिनिस्टर वाज अ टूम, बेसिकली मकबरा था उसके गांव में किसी सेंट का. और उसने कहा ये बिल्कुल उसी की तरह का लगता है जैसे बकमिनिस्टर का टूम. But they are football shaped and they have hexagons. They have football पे जैसे बने होते हैं, sort of hexagon भी बने होते हैं और शायद फुटबॉल पे पेंटागॉन्स भी बने होते हैं. तो इसी तरह से हैं. And they are considered to be very like amazing discovery because some changes can be made at different points. Scientists are trying to attach some molecules with these simple molecules or react them together or with other things and produce some new things. अब अगर देखें फुलरेन्स को, he named them as Buckminster fullerenes for these reasons. A little comparison can come, like it is a poor conductor of electricity compared with graphite because graphite has, you see, delocalized electrons and certain solubility of these small molecules. कार्बन है तो शायद कार्बन टाइप में मटेरियल्स लाइक इथाइल बेंजीन में या डाइसल्फाइड में, सम ऑर्गेनिक सॉल्वेंट्स में, इनऑर्गेनिक है डाइसल्फाइड, अगर उसमें भी सॉल्युबल हो जाते हैं कुछ सम एक्सटेंट तक. Smaller molecules need less energy to break up, so they may be more reactive than others. तो आपने ये वाले points जो हैं, because it's a sort of theoretical things. Inorganic में भी जाके हमें इस तरह की चीजें आएंगी जो हमें कुछ याद रखनी पड़ती हैं. Look at the number of the carbon atoms, their general shape, hexagon and pentagons, and smaller molecules, lesser boiling points. Graphite only turns from the solid to the vapor at about 3700. Huge. But this one, these simple molecules normally at 600 it takes up. Okay. Okay, then this is nanotubes. अब देखिए लिखा तो होता है कि nanotubes and graphene are not the part of the syllabus, but you may be asked certain questions and stuff and all. But these nanotubes are, आपने सुना होगा nanoparticles. You might have heard about the carbon. You might have heard about that. What do you call this? Carbon fibers. Carbon fibers mean a graphite layer. A graphite layer may be rolled into a U-shaped structure. And when graphite layer is rolled into a sort of U-shaped structure, one layer can be called as a nanoparticle. And then another layer is introduced, and another layer is introduced. It means extent of covalent bonds, extents of packing has gone to the maximum of the limit. Because human discovery है ये, आपने बनाई है, graphite को उठा के, ग्रेफीन को उठा के उसका रोल करके यू शेप स्ट्रक्चर बना दिया आपने. और फिर जापानीज केमिस्ट 1991 आई थिंक, वेरी रिसेंट दे स्टार्टेड. So when you roll that into the U-shaped structures and you are fixing in more and more layers, it means you are increasing in the density of what? The carbon atoms. And when there are so many carbon atoms, they are linking with each other, and so many covalent bonds, it becomes such an extensive macromolecule. It is said its hardness can be much more than diamond or maybe steel, and can be thinner than the human hair. Then इतनी थोड़ी सी चीज की भी स्ट्रेंथ इतनी ज्यादा हो जाएगी. So you call them as carbon nanotubes and nanoparticles and nanotechnology and carbon fibers. तो हम प्लास्टिक के साथ या कुछ मेटल्स के साथ, सम वुडन स्टफ के साथ भी मिक्स करके कार्बन फाइबर्स रखते हैं और हाइड इसमें स्पेसिफिक हार्डनेस आती है. बट द टेक्नोलॉजी इज वे टू एक्सपेंसिव. अब एक स्पोर्ट्स रैकेट अगर खरीदें, टेनिस रैकेट, तो आपको पता चलेगा इट इज लाइक 150 to 100,000 का आ रहा होता है पाकिस्तान. Reason is the technology, because it's not easy to pick a single layer of the graphite, because that single layer of the graphite is called as graphene. This is graphene, a single layer of the graphite, if you can pick it up. And normally there's a lot of new like work जो इस पे जा रहा है. You can say a sort of synthetic materials में. This is also a huge revolution, because इतना thin करके you can make such a strong material that sometimes it is a sort of invisible block somewhere, and you may go and just somehow just collide with it, or it can be an invisible cage. आप ये के ड्रामाज में, इन चीज़ों में, जापानीज में, चाइनीज, इस तरह की चीज़ें वो करते हैं, बट स्टिल इट इज नॉट दैट इम्प्रैक्टिकल, नॉट मच. बट अगर इम्पोर्टेंस है तो ये है कि यू कैन मेक अ थिन वायर आउट ऑफ इट, अ थिन फाइबर आउट ऑफ इट, and you can introduce medicines to different parts of the body using these kind of things made out of carbon nanotubes, nanoparticles, or these graphene. It means a longer pipes that can pierce the skin, goes in, deliver the medicines, come back, etc. These kind of things can be used. Or when you have taken one layer out of the graphite, one layer, again the particle size becomes small, they may break up. That's why their reactivity may increase. Single sheets of graphene burn at a very low temperature. Of course, वैसे जैसे लकड़ी के छोटे parts कर दें उसको आग जल्दी लग जाएगी, ऑक्सीजन कम चाहिए. Particle size small, surface area to volume ratio ज़्यादा हो जाती है. It's extremely strong for its mass. And why the strength is there? Because carbon atoms are holding each other. And when they have free electrons, then if you are holding these graphenes in a form of a nanotube or a nanoparticle or even a layered structure, and you are concentrating the number of carbon atoms, it means you are concentrating the number of electrons inside, delocalized electrons. तो आप कुछ बहुत ही thin wire conducting material बना सकते हैं इससे. Okay, much better conductors. So amazing, wonderful, some new discoveries में इनकी conductivity आती है. It has been said that a square meter hammock made of graphene would support a 4 kg cat, but who would weigh only as much as the cat's whisker. Potential application of graphene include use in tiny electrical circuits and for any tiny transistors, touch screens, solar cells, and other energy storage devices. आपको जनरली 2-4 बातें इनकी जरूर आनी चाहिए इन डिस्कशन. आइडिया कहाँ से आया? आलोट्रोप से. किसके आलोट्रोप से? ये किंग ऑफ द एलिमेंट्स. क्या है किंग? कार्बन. In the form of diamond, it is unique. In the form of graphite, it has amazing. In the form of soot, smoke, it may be irritating. Okay, but in the form of charcoal and coke, it has huge use for industrial production. Rather, industrial revolution अगर आई है तो coal, coke, etc. को combust करके आपने trains लाई और चीजें बनाई. But सुना होगा आपने कि you can transform diamond, coal into diamond. Of course, at such high pressures and temperature and precise conditions of picking and attaching, I think Russian chemists or बाद में Chinese ने किया है कि they have changed this coal into diamond-like, but that is way too expensive than exploring the diamond, finding it out in natural diamonds. So that may be an ambitious project. But rolling in the form of U-shaped structure and increasing the concentration of carbon to carbon atoms, and then the delocalized electrons, you can make nanoparticles, what you call as carbon nanotubes, carbon fibers. And if you can take one layer of graphite, that is graphene, and these layered arranged in a certain structure will be extremely useful for making sportswear stuff and car parts, engine parts, and especially for electrical normal जो हमारे modern gadgets हैं तो उनके लिए बहुत कुछ आप कर सकते हैं. So my battery possibly is going down. So आपने इन क्वेश्चंस को सजेस्ट हुआ है, हम कल भी करेंगे. इस चैप्टर को कल हम क्लोज करेंगे. आपको शायद बोरिंग भी लग रहा हो कि हम इतना कुछ कर रहे हैं, लाइक इसके पार्ट्स करने पड़ेंगे, बट दीज आर ग्रेट हेल्प फॉर रेस्ट ऑफ द केमिस्ट्री. We'll try to discuss these questions tomorrow. Yes.
When will the test take place?
Sorry, I can't hear it properly. क्या कह रहे हैं आप? Any question?
I'm asking test कब होगा?
आपका जो माइक है ना वो सही नहीं है. Will you say it again? कौन पूछ रहा था कुछ? पूछते ही नहीं आप लोग क्वेश्चंस. Fatma, you have any question? Fatma Imran?
जी सर मेरे पास है. मैंने ना आपसे एकेडमी में आई थी अराउंड 6:11 आपसे सवाल पूछने, लेकिन आप चले गए थे. मैंने आप
सॉरी.
ओह सॉरी, मुझे याद आ गया आपने दूसरी एकेडमी जाना होता है. हाँ
हाँ, लेकिन आपने थोड़ा सा पहले मुझे कर लेते तो मैं आपको बता देता. लाइक आप जब भी क्लास चल रही होती है तब आप आया करें, बिकॉज व्हेन इट फिनिशेस देन आई हैव टू मूव ऑन. ठीक है ना?
सर, क्योंकि वो बहुत ही ज्यादा क्वेश्चन है मेरे पास, और लाइक मैं जरा फर्स्ट चैप्टर अपना ना स्ट्रॉन्ग बहुत कर रही हूँ
ओके,
इसलिए.
बट वंस वी स्टार्ट देन हम कर लेंगे, और आप उसको भी व्हाट्सएप भी कर लिया करें. ठीक है ना?
ठीक है सर.
तो कल इंशाल्लाह हम इन चैप्टर्स को, इन क्वेश्चंस को भी डिस्कस करेंगे और इस चैप्टर को क्लोज कर देंगे इंशाल्लाह. ठीक है ना? अल्लाह हाफिज क्लास.
अल्लाह हाफिज़ सर.